So getting into the second half of the notes here for section 2.3, I've got this into the classroom bit of information. It's helping to teach addition facts. I every so often in the notes, actually grab these from the textbook, things that I thought might be helpful or useful to you. I've got these thrown in the notes. I'm not going to read through them, but just it's there possibly as a help for you in the future. But I want to talk about subtraction here. So instead of adding, we're now going to be subtracting numbers, so the difference of two numbers. And subtraction, mathematically, it's the inverse of addition. So here, if A is equal to B plus C, subtraction is defined so that A minus B is C. So subtraction and addition do go hand in hand. And I want to, before we get into ways to describe subtraction, I want to give you a couple definitions here. It says when you're subtracting, you have A minus B. The first number, in this case, the A represents it, is called the minuend. And the second number, the number that's being subtracted, is the subtrahend or subtrahend. So we do have very specific terminology for the two numbers that are being subtracted. A lot of times you don't hear these used, but they do exist, so I want to share them with you. On the next page of notes, I have a few different models for showing subtraction. There is the takeaway model. So if you are trying to show 8 minus 5, you can start with 8 objects. Here we have 8 tiles. And then if you take away 5, how many are left? There's our 3. If you want to show the relationship with subtraction to addition, you can use the missing add-in model. So we're going to start with 5, and then how many more tiles or how many more objects will we need to add to this to get a total of 8? And again, that can be used to show the relationship between subtraction and addition. You can also use the comparison model. So this was used in showing less thans or greater thans, but you can also use it for subtraction. If you've got 8 of one object, 5 of another, line them up. How many are unmatched? That's our difference, okay? So 8 minus 5 is 3. And then you can also use the number line model. It says in the note here, make sure you put arrowheads together for subtracting and draw the subtrahend arrow backwards from head to tail. So let me show you how this is going to work exactly. So here we're going to look at 7 minus 4. So I'm going to start by representing 7 on my number line. So I'm going to start at 0, and I'm going to jump over here to 7. To do the minus 4, okay, let me actually change to a different color here to make this even more visible. So I've got my arrows at the 7, and I want to go back 4 units. So 1, 2, 3, 4. So I'm going to end up here, right? What's my answer? 3. Where do I end up? Okay, so it's maybe works a little counterintuitive using the number line this way, but I just want to explain that process as well. So this is 4 different ways that subtraction can be modeled. Very hands-on ways. You could use different methods with different age kids, and obviously as you're progressing, you can move to the more abstract number line model. On the last page, I want to talk really quickly about fact families, which you might be familiar with. So addition and subtraction are related. And so we can write our 2 addition and our 2 subtraction facts with a set of 3 numbers. We can write those as a fact family. So for instance, 5 plus 7 is 12. But because of the commutative property, we could say that 7 plus 5 is also equal to 12. And then with subtraction, same three numbers, we can say 12 minus 7 is 5, and 12 minus 5 is 7. That's what we call a fact family. So here I've got, what is the fact family that contains 12 minus 4 is 8? So I'm going to write 12 minus 4 is 8 here. That's the same thing as saying 8 plus 4 is 12. Commutative property tells me 4 plus 8 is 12. And then 12 minus 8 is 4. So those are fact families. So if you hear that phrase, that's all it's referring to. And it's actually very important to learn that addition and subtraction are so interrelated to one another. The last example, this is a little bit of a brain teaser. And you might have seen on social media, people will ask some mathematical questions, and depending on how well people know order of operations, they might come up with a multitude of different answers. But when we put in parentheses, order of operations says you work your parentheses first, but depending where those parentheses are placed, you might get vastly different answers. So here we're asked to place parentheses to turn these inequalities into true statements. So if we look at this first one here, we have 8 minus 5. If I were just to read this from left to right, that would be 3. 3 plus 2 is 5, minus 1 is 4. Certainly not equal to 0, but we can put some parentheses in to make this a true statement. In this first case, if I put parentheses around our middle two numbers, it tells me that I need to add those first. 5 plus 2 is now 7, so we have 8 minus 7 minus 1, and that is equal to 0. So our second one, we have the same four numbers on the left, the 8, 5, 2, and 1, but the signs are slightly different. And this time we want them to equal 10. So you can play around with your parentheses here. If you want to try this on your own, you can hit pause and come back to it. But in this case, it's going to require two sets of parentheses. You can put a set of parentheses around the first two numbers and then around the second two numbers. So we now have 8 plus 5, which is 13, minus 2 plus 1, which is 3, and that is equal to 10.